Okay, I think we are streaming. Alright, welcome back to episode 5 of amplifier repairs. Hopefully today we'll make it through a complete repair. I don't want to say we're going to try and get to another one because we usually don't, but we're going to start off with this one and see how we end up. We're going to be working on an RT-10. I just pulled it out of the box and I haven't done anything to it yet, so this will be from start to finish. I went back to using my USB wired microphone. I hate having wires attached to me, but I had some problems with audio cutting out and I really don't want to deal with that again. Looks like my microphone volume is a little on the loud side, so we're going to adjust that really quick. Stand by, and we'll get to this repair in just a minute. I guess I could adjust the volume in studio, but I like to have my settings permanent. That way I don't have to deal with changing them every time. And that looks to be a little bit better. This microphone has gain control on it, so it might override my settings anyways, but alright, let's get onto the bench and see what we got here. Oh good, the camera's reset too. That's what happens when you do a lovely Windows 10 update. Alright, well you can see the bench at least. Let's get zoomed in here, see what we're working with. And I still do not have a remote for my camera, so you have to bear with the jerky mouse clicks. Alright, here we go. So the customer says that every time he puts a new fuse in, the fuse blows. 99.9% of the time when that happens, it's this board right here. There's glue on it. It's going to be a little hard to see, but you know, down inside there, it's all kind of crusty and nasty. You can maybe see it down in here by this cap, but these are almost always glue failures. These are extreme. This is an RT-10. This is very similar to the RW-10, RW-12, and all the digital versions too, RW-10 and 12D and a few of the other ones. But this power supply here is used in a bunch of different manufacturer subs. Klipsch uses it. I think JBL uses it. A bunch of different manufacturers used this bash amp power supply. So I'm not going to power it up. I know it's blowing fuses, so I'm just going to pull the power supply out and we'll start there. The FETs are probably toast. Usually when this board goes, the FETs are also gone too. Sometimes the gate drive resistors will test those. And we'll just kind of step by step go through. If you're pulling these connectors off, I'm going to remind everybody, make sure that you depress the little locking tab in there. Just push it down, and then they come off real easy. And the power supply ones have it too. Razor blade's probably not the best tool to use, but that's what I have right now. So it's been a while since I've actually worked on one of these, so it's nice to do something different for a change and get away from the RT series and the RS or the R112s and 115s. Those seem to be the newer items that are failing a lot right now, so some of these older ones are kind of fun to work on. And you can tell this one's kind of old because the knobs have got a gold color from being in the sun. Aluminum, when it's anodized black, turns gold after UV hits it for a long time. It's actually kind of cool. If you have anything like any old gear that's made out of aluminum and it's black and you want it to look kind of cool, leave it out in the sun for like a whole summer and it'll turn that gold color. kind of cool. Alright, we'll set the amp aside. See what's going on with this power supply. So there's nothing burned on it, which is good. There's been no previous work done on it, which is also good. But it is kind of smothered with glue. It's really bad down in here off the little cap to the dashboard. I'm gonna say it's the dashboard. Let's see if our FETs are shorted. You sure are. I think it's just this one, but we're going to have to pull them out either way. So we'll just take this apart and start pulling everything off of it and see where we end up. These screws are a pain because they put a bunch of glue on the back of the nuts. I have not really found an easy way to get them off. You just kind of got to muscle through it. This one's actually not too bad. The screwdriver's a little big for what I'm doing as well, but that is okay. Sometimes you can peel the little blobs off, but I don't know what this is. It's like some kind of an epoxy, or I don't know, a dab of Loctite. Blue would have been just fine. I guess they were worried about these vibrating free, even though they do have a lock washer on them. So break the glue, because you're going to need to wobble these to get them out. The goal tonight is to not do any damage to this board. And since nobody's messed with it, I think we got a pretty good shot. If you watch the last repair video, you can see how many through holes had to be redone and traces, and that's never fun. So we're heating up. That's going to take a minute. Let's see what else we got in here. The dashboard looks pretty good. Sometimes this glue turns a little brown. It's still a nice yellow color, so chances are that's going to be okay. All the caps got to be replaced. I don't even question that anymore. They just come out. It's interesting that this one uses the little stubby versions. I haven't seen those in a while. I do have some, but I usually put the taller ones back in. I don't even know what value these are. I think they're 470s. No, these are 220s. 220 microfarad and 200 volt. Let's see if I have some shorties while we heat up the desoldering. I do. Look at that. We'll put a couple of shorties back in there. Keep it original. Not that it matters, but just for fun. And I don't feel like looking for the larger ones. We are going to need a big one, which is 1,000 at 100 volts. I have 1,000 at 160 volts, 1,000 at 200 volts. There we go. Is that a snap-in? I don't know. It's 160. Yeah, we'll use a through hole, that's fine. UPS, these are good caps. And for the cans, I'm using, I believe, the GR series. These are pretty good too. LGU, LGR. They're all pretty good caps, and they're all Nichicon or Nishon or however you want to say it. But that's what I use. What do we have in here? Junfus? No, these are DM. I don't know what DM is. They should be called DC for damn cheap, but that's alright. Gotta remember that these amps are not made by Klipsch, they're made by Indigo. And Klipsch just says, hey, I need an amp that puts out this much power, I want to put it in my sub, and that's what you get. But it is a Chinese made amp. I think it's Canadian designed, but Chinese made. Putting a little lead on there just to make it easier to get these off. And I suppose you could cut the legs if you want to reach in there and do it, but I'm just going to wobble them a little bit. I think we got 2 out of 3 on that one. If you don't have one of these, always cut the legs. You'll do a lot less damage to the board if you cut the legs. And when you get things loose, don't just rip them out, you know, give them a little wiggle, make sure that all the solder is broken free. Sometimes, you know, they'll get stuck a little bit in there still, and you'll tear the through hole out. Just kind of wiggle them, shake them a little bit. Take them out slowly. We're not really in a major rush here to try and destroy stuff, so that is the secret. And it came out clean, none of the through holes are damaged. That's the goal. Alright. And we were correct. Only one of them's blown, but we're still going to replace both of them. So we need some new FETs. The bash board is going to come out. These boards too, these are kind of interesting because these boards were configured for use over in Europe because you can run them on 220. And the way you do that is you change these jumpers, and normally if I'm working on one and it's a US amp, I put solid wires in where the jumpers are. You don't have to do it, but I clean the glue out of there, and you know it's kind of in the way, so I take it out anyways and put jumpers in there. But if you wanted to, you can also run your amp off of 220 if you really wanted to. I don't think you really gain a whole lot. These don't really draw high current, but that is an option on some of these, which is kind of neat. They are universal for use on whatever voltage you want to run them at. And we're going to pull the Pdc board out. But first, again, we're going to put some lead on there. And you can be messy when you're doing this part too. It's fine. We just want to glob a bunch of solder on there to dilute the lead-free stuff, because lead-free is a pain to work with. Make sure that we can shake it a little bit. Always keep a little diode around so you can clean your tip. When your fingers start to burn, you know it's clean. Same thing, we're going to shake the board a little bit back and forth, heat it up, and then clear the joint. Sometimes you have to do this multiple times. It all depends on how much the board can actually move. And these are a little harder to clear because the plastic that holds this header on is like right up against the other side of the through holes. So that plastic kind of blocks the airflow. But the cheat, you can just resolder the ones that are on there and suck them through again. As long as you keep the board moving, they tend to... Tell me that's not a bent pin on there. No, okay, we're good. So it looks like the first two have to be redone, so we'll solder them back on. And clear them again. And you can see which pins are moving when you're shaking the board back and forth. It looks like I have one more that, maybe two more. I'll do these two in the middle again as well. You don't want to keep the iron on there too long, because then you do risk lifting the pads up, because these boards are pretty cheap. So you're better off wiggling the board. And you'll feel it when it comes free, and this one's pretty good now. I can shake it back and forth. All the pins are moving. And, we're going to keep wiggling in there, trying to, break free any of the solder that remains. Once it's, kind of loose like that, it's ready to come out. And just kind of wobble it gently back and forth, and it's out. And none of the through holes are with it. Success. We're off to a good start today. So let's jinx it by announcing that. Why not? So while we have this out, we'll check the gate drive resistors. They're either 100 ohms or 220. So we'll give them a measure real quick. 235, so that's going to be 220. We'll call that good. That's within 10%. And these might actually be to some weird number. Hard to tell with the bands, but they're both reading the same. Close enough for me. And they're reading the same number. That's even better. It's not even worth seeing what the values actually marked are. So now comes the fun part. Busting out all the nasty glue. These film caps are rarely ever bad. I typically don't replace them unless they are bad. And when they are bad, you will definitely see it because they will be burnt to a crisp. I still scrape some of the glue off. I'm just trying to clean them up a little bit and make them not as nasty. This is where the glue is bad. Let me pull this out of here. I know it's hard to see kind of zoomed out, but that's black. That's carbon right there. That is conductive carbon. That is exactly what you do not want on your amp, and it's all over these caps too. So there is a little bit of good glue connecting the film caps to those. So what we're going to do is we're going to break that connection by jamming a razor blade down there, X-Acto knife. Anywhere where these big caps are connected, we're going to make sure it's disconnected. And since these are glued on pretty good, you got to get kind of creative pulling them out. I got to do a tip change real quick. Go to the large tip. We're going to pull all the caps out. If you're going to cool off your iron, make sure you're doing it in water. Don't dip it in your alcohol container. But they come out real good when you cool them off just a little bit. Don't set them on anything flammable either. That's probably not a good idea. And don't touch them. Don't touch the hot ones, that is. The cold ones are fine. But dunk it in water, you save a little time changing tips out, because that one shrinks right away and comes right out, and then the new one's already at 540 C, so we're almost back in business with minimal delay. So these PDC boards, this one actually doesn't look too bad. Most of this diode right here looks a little weird. We might check him out. I'll zoom in when we get to it, but most of the time this guy up here is bad, and this is a diac. So let me get these caps out, and then we'll... Actually, I'm just going to recap the board first, and then we'll get to the PDC board. We can check the output. Actually, these are the... no, yeah, this is the output. This is the output diode and switch for the buck converter, which is the second stage of the power supply. Come on, camera. Be nice to me. It doesn't want to focus. There we go. So same thing, we're going to load up these pins, just throw a bunch of leaded solder on them. If you previously just tried to power this thing on, I would definitely make sure you drain them, but this has been sitting in a box for a couple weeks, so I'm not too worried about it. These you can't really wiggle too much. You can try, but they're snapping, so they're kind of hard to jiggle and shake around. That leg was loose and resoldered. That came out way easier than they usually do. This top one will be a little more difficult. Normally I gotta put a pair of pliers on them and literally rip them out of the board. Yeah, this one I'll have to do that too. The whole board's flexing. So I clear the holes as best I can. And I'll take a pair of whatever pliers I have. Just try and free up the pins a little bit. This one's still soldered in. And the problem is you can't get any air in there. And for the solder sucker to clear them, it needs somewhere for the air to flow through. And these things are glued so hard to the board, you can't really get any air in there. And you don't need to glue these to the circuit board. The solder joints on them are pretty beefy. Alright, so I have to grab a pair of decent sized pliers, which I might have to go find because I don't think they're... Oh, no, here they are. And we don't care if we damage the cap, but we're just going to grab it and snap it out. And you might lose a little bit of the through hole with it. If you lose too much of the through hole or the pad, it's going to have to be fixed. And we lost a little bit in the top, so we'll put a new through hole in there. Sometimes there's just nothing you can do about it. When they're glued down that bad, you always risk a little bit of tear out. have one leg that's free and one leg that is not. And this one has a lot of glue on it, so we're really gonna have to yank and mess around with them. Try not to break the board though, too. You know, crack it free. You can always go back once you have one leg moving and hit it with some heat and see if you can get the other one free. And this one does not want to budge. Put a new blob on there, heat it up, and start over. And now it wants to move. We broke the glue joint, so we'll get it heated up. That one came out a little nicer. Well, you can see how easy it is to tear pads out. And, I mean, this one was just completely slobbered with glue, so not much we can do there. Well, sometimes this stuff comes off pretty easy. Sometimes it does not. It all depends. If it's crispy, it usually comes off fairly nice, and you don't have to heat it up. If it's still kind of rubbery and yellow, you're gonna fight it. And you don't, you know, get as much of it off as you can. You don't need to scrape down into the copper layers. Don't take the solder mask off. Just get the glue off. These flat blade razors that go in the X-Acto knives are awesome for this. It's just like a little chisel. You can see the little jumpers that change the voltage right here. Let me zoom in a little bit more. I'm kind of far out. But you can see the jumpers that when they're on the outside, that's 120 volts, and when they're on the two inside positions, that's for 230 or 220 or however you want to run it. These green guys here, inrush limiters. This is it's DSP 104, so that's 10 ohms, 4 amps. A lot of times those are bad when the FETs are blown, so we can do a quick little check. Put your meter on ohms and just read it. See what it reads. So it's reading 14 ohms in circuit. So as long as there's no physical damage on there, and what you're looking for is like a little black hole or like a chunk blown out or a crack, as long as you don't see any of that, you're good to go. You can leave that in. But give it a good look over and make sure there's no damage or nothing missing out of it. Most of the time these do need to be replaced. Today, I think we got lucky. Typically what happens is your fuse will blow. You put a new fuse in, the fuse blows again. So you're like, okay, I don't know what to do. So then, you know, whoever's working on it, they'll put a 10 amp fuse in there or a 20 amp, you know, whatever bigger size fuse they can get. And when you keep going up in fuse size, that's when you start to damage all this stuff over here. If you know, if it's rated for 3.15 amps, like don't put a 10 amp fuse. Don't even put a 5 amp fuse in it. Put the proper fuse in it, because that's designed to actually protect what you're going to blow up when you put a larger fuse in there. And I see that a lot. It's everybody's first go-to is, oh, we need more fuse. Definitely not how to, the right solution to fix any problem with these. I'm going to jumper these. We'll pull them out if I can get them out. That one came out pretty easy, so did that one. I leave them soldered in and try to get the base piece off first, because it makes it way easier to get them out. So if you just kind of work it a little bit, you can pull off the plastic piece of the header. And now the pins come out like a dream. And my solder sucker's still hot, so we'll let them up. I'm not even going to change tips, we'll just use the large tip. They might even fall out when you're heating it up. Get them good and gunked up. Makes it easier to clear the holes. But again, this is the easy way to take out a header without doing damage. If we're not going to use the header, we don't really need it in there, so just pull them out pin by pin. It's a little extra work to do it this way, but I don't know. Jumpers on a power supply line is not really ideal in my opinion, so a little piece of wire I think serves you better. Now we can clear the holes. Extra 2 minutes of work. I don't think anybody's going to be upset by that. By the way, if you are going to switch the voltage on your unit, make sure you add a cap if your system only has one. Some of these only have one cap on the input side, and it is not rated for the voltage. If you have two, you're okay. And if you have one, these are only rated 200 volts. No good. Now the glue on the other side up here by this cap, that's going to be a little more difficult to get out. We're also going to take off the glue that is down here. We can leave it up here, that ain't going to hurt anything. But anywhere, and even on these it's fine, but anywhere where it's touching the board, it's got to come off. And this little bit of film that's on here on the top, that ain't gonna really hurt nothing. But you know, do the best you can to get it cleaned up. Keep a garbage can nearby so you can clean off your desk periodically. Like, you know, all this stuff is making a mess. My trusty dental pick, we're going to set the heat for 120°C. And this we're going to heat up. Be careful, you know, not to blast too much heat in there, because if there's film caps close by, you'll kill the film caps. 120°C is about as hot as you ever want to be when you're working around components. Most of them are only really rated for up to 150. resistors and you know, passives not too bad, but anything else, you just don't overheat it. It takes a little more time to use at a lower temperature, but it doesn't create as much like smell and smoke, and you're not really risking damaging anything. Sometimes you can get it off in chunks if you're lucky. Which we seem to be today. I'll take it. Try as best you can not to scrape the solder mask off too. Because these underneath all these caps are big power planes, so if you can avoid it, try not to interrupt those, because the bottom of the cans of the caps are aluminum, and if the little mylar film or whatever's on there wears off, then you're going to risk shorting stuff out. It's uncommon, but it could happen. And down here we're kind of limited to our approach. We got to put some heat by the cap. I don't like doing that, but there's really no other way to get this glue out of here. I'm going to try and trim some of it off, see if I can gently cut into it below the cap. Don't cut into the cap, that would suck, because I don't think I have any of those. Problem is once this stuff cools off, it gets really hard and rubbery again, so it's extremely difficult to pull out. I think we got just enough heat to get it out. But it starts to get like that plastic rubbery consistency again, and just take your time. That's the name of the game. Take your time. And be careful with these little ceramic bead caps, because they are kind of flimsy and you will break the leads. So if you gotta put a little more heat in there to separate the glue from them, just do it. A little bit of residue isn't gonna hurt anything, but too much and you risk having shorts. So I'm going to call that good enough. Get most of it off. There's a few little pieces on the sides of the cap, but it's really not risking shorting anything. This little bit on the top of this resistor isn't going to hurt nothing. You can scrape it a tiny little bit if you want to. A little bit on that film cap ain't going to hurt nothing. If you want to just like kind of smooth it out to make it look nice, that's fine. You don't have to go too crazy, just crazy enough to make sure that it's not going to short out on you. So next we are going to do the electrolytics on here, and these ones don't have as many as the other amps. There's just the large ones and these 3 right here. The rest of them are on the I guess you would call it intermediate board. It's not a feature board. Actually, I think it's the amplifier board. It has the plus and minus 15 volt regulators on it. I'm going to switch tips. These I am going to snip out. And the reason I'm going to do that is because all the leads are folded over. Need to get some more water. Do that when I take my break. So what do we got? Who makes these things? Junfu capacitors. Best capacitors ever made. Junfu. I think the initials on them are FU for a reason, because that's what happens when you leave them into electronics. And that can be interpreted a few different ways. So C419, C418, 47 microfarad, 50 volts. It's one of our probably most common capacitors. And these are both marked with both the square pads and the line. Square pads being positive and line obviously being negative. I'm going to try and pull the leads out from the top. We're going to have to add some fresh solder. Nice big blobs. Normally I do this with my iron, but I just feel like doing it with this tonight, so we'll see. See how it plays out. Pull your leads out and then clear the holes. If you have a manual solder sucker, I guess you could do it if you were heating one side of the pad with your iron and then sucking from the other side after you clear the holes. I would never use one of those little handheld solder suckers to remove a component. When I first started doing this, that's what I was using, and I damaged a lot of boards. And I actually stopped working and doing repairs for a while because I was frustrated. I didn't know how I could continue working on them without damaging the boards. And then one day at work, I saw this solder sucker, and I liked it so much, I went out and bought one the next day on eBay. And it has made everything better. Even for little hobby-related things, it's a good tool to have. If you're going to do electronic stuff, you should have one of those. Make sure your caps are in the right orientation. Don't bend the leads. Oh, the dog's coming down. I gotta say hi to my dog if she comes down here, so be ready for it. It's gonna happen. Hey, come here. Hi. Hi, dog. Lay down on your bed. Can't have a workshop without a place for the dog. That's a must. You just have to have it. Alright, so one more cap on here. It is a 22 50 volt. Those are also pretty common. And yes, these are still hot when I'm pulling them out. And yes, I have burned my fingers numerous times doing it like this. Just be fast and you'll be alright. So one of the things that it's going to help to have is you really need a testing amplifier, like a known good board, because when it gets to this guy, you don't want to be putting it in, pulling it out, putting it in, pulling it out. Like it's better if you can put it in once and you know it's good, and then move on to the next part of the circuit if you know that you have a problem with it. So we'll get to that in a minute. I have a sub 12, I believe it is, and we will use that as our testing fixture. I put a socket in it already, and it's good to go for testing. Again, we're checking to make sure that our negative is where it's supposed to be. Dog's got to go outside. Always has to go out when I'm doing a stream. I need to change my BRB message to letting the dog out message. You can't chill for a minute? You gotta go outside right now? Drive me nuts, dog. But I still love you. Alright, well, if you're watching along, hold on, I gotta let my dog out. I'll be back in a couple of minutes. Alright, that wasn't too bad. Short little intermission. Okay, so we have the caps in. We're good there. Triple check our polarities, those are good. Let's put our larger caps in. Now, these boards are designed to take two different sizes. You can use a snap-in or you can use a through-hole. If you use the through-hole, actually use the little through-hole, because then the cap sits nice and flat. From the factory, they didn't use the through-hole, they used a large hole for the snap-in, and they bent the leads. I don't know why, it's totally pointless to do it that way. And just make sure we're 100 volts, 1000 micro. So I don't get it. They fit really nicely in there if you use the through hole, and that through hole was added onto this circuit so you could use either a snap-in or a leaded cap. It seems crazy not to use it. Tack it in place. Get a nice fillet on there. Check our polarity, we're good. Alright, before I put these caps in, I'm going to put the jumpers in. And what you can use, believe it or not, are the little pins that we took out from where the jumpers actually were. You can use the legs of a resistor, you could use pieces of wire, you can use a lot of different things, but we have these nice thicker gauge pins here. Why not use these? A little difficult to bend. We'll get them. You can get a pair of pliers if you want to and really get some squeeze on them. Now we got a nice little jumper, and we didn't have to use anything but what we already had. Again, this step is pretty much optional, but I like to do it. I don't know. If nothing else, it gets rid of all the glue that was down over in there. And they don't have to sit down in there perfect and pretty. I mean, if you really want to, you can make them, but they were originally jumpers, so anything solid is going to be better than that. We don't have to worry about them vibrating loose at that point either. Make sure you put them in the correct spot though. If you're working on a 120 volt system, make sure you put the jumpers in the proper spot, otherwise when you turn on the amp you're not going to have the right output. Power supply might not even fire. I don't know, I've never tried that before. I don't know how that would work. It might come on, but it won't work well, put it that way. Or if they're in the 120 spot and you hook it up to 220, you're going to nuke your caps. Don't want to do that either. These large caps aren't cheap. So we'll tack one leg in, we'll make them sit nice and flat. Looks alright. You're going to touch these, use your fingernail. Fingernails don't conduct heat as well as skin does. If you touch it with your finger, you're going to know in about a second because you're going to have a nice little blister there. Make sure you got a good joint. Check the top. Make sure it's soldered in pretty good on the top. Put a little more on this one here. A little more heat. Good enough. That ain't going nowhere. Alright, now we can put the big caps in. We gotta do a through hole. Forgot about that. We'll do that next. We'll put one cap in. Listen to our annoying meter beep at us because we didn't shut it off. Alright, now I could just solder this cap in because the connection's actually made on the bottom of the board, but I don't know, I consider that a bogus repair. It's cutting corners. I don't really like cutting corners, especially when I'm doing work for somebody else, so we will fix it properly. So to do that, we're just going to take our largest through hole that we have. I'm going to try and get that number on the screen. I know these are made by Best. www.solder.net. I am not sponsored. I don't know anybody that works there. I just know they make pretty damn good through holes, so that's what I use. They're definitely not cheap, but if you're doing quality work and quality repairs, you need quality quality parts to do your repairs with. I'm not sure if I'm using my largest size. I'm going to try a different one. That's my big one. It's just a little loose, but it'll tighten up once we form it in there. And this is just to replace, you know, there is still some of the through hole left in there, but when we pulled the old cap out, it took a decent chunk of it with it, so this just makes it better. Will it function if I didn't do this? Yep. But I wouldn't feel as good about the repair, so. Now it's definitely good. Headphones are falling off there, sorry. Hopefully I got that muted in time. So when you do replace these, they don't usually pop in, so you have to put a little pressure on them to pop them in. Now our solder connection's on the bottom, so I left the little funnel part of the through hole on the bottom so we can get a nice fillet and it'll fill that all in. It's purely for mechanical connection at that point, so that's how I do it. Alright, so let's solder this guy in. Make sure it's seated fully flush with the bottom of the board. And be generous with the solder, you know, get a nice fillet on there, don't skimp. You don't want cold solder joints, those suck. Cold solder joints will just create intermittent problems down the road. And then we'll be getting a call from somebody in about a year like, hey, this thing's like buzzing, or this thing's not working, or just no fun. Here's another pet peeve, so we're going to get to this next. So it's probably hard to see on the camera, but the FETs are not straight up and down with the heatsink. They're kind of on an angle. And whenever they designed this board, like, they must have not measured this part accurately, or they made a mistake, or whatever the reasoning was. But it drives me nuts that these aren't straight, because when I go to put this thing back together, I have to put them on the right angle, otherwise they won't go into the board. It's really annoying, and a lot of these amplifiers have this issue. It seems like I don't know, a few extra minutes would have saved some headaches during assembly time, but that's not how they did it. I'll scrape some of the nasty glue off. It doesn't really matter on the backside, but I gotta get to these screws, and I might not be able to even get a screwdriver in these, to be honest with you, because there's so much of this glue on here. Usually they use that green or a clear stuff on here, but every once in a while you'll find a surprise. Maybe they were out of it that day. This just makes it an extra pain to clean off. What you can do, here's a cool little trick. Take your hot air. We're still at 120°C. We're going to heat up the head of the screw. You can actually go hotter for this if you want. Heat it up, and then just take your screwdriver and push it down into the screw. That'll at least let you get some grip on it. And this works with the clear stuff too. If you can't pick it out, sometimes I just don't want to pick it out. Just get it soft enough to where you can start the screwdriver in there. And just work it down in. It's these little annoying assembly things that you gotta learn to, make shortcuts with. This was so loose I didn't even need to put a pair of pliers on it. Even with the green goo on there, I don't know what that stuff is, but so let's see what these are. I can actually read them. They're 740s. Alright, 2 IRF 740s coming up. Double check them to make sure I didn't put them in the wrong bin. So there's still way more than enough thermal paste on these, so and it's clean, I'm just gonna take the Q-tip and smear it around a little bit, get some of this extra stuff on there, put a little more on the top. Again, with thermal paste, you don't need a lot of thermal paste, you only need a very, very little bit. It is a common misconception that you need to have the surfaces like fully coated with this stuff. You want a transparent film, enough to fill the voids in the device, but to not create like a gap between the device and the heatsink. When this stuff is applied too thick, it is an insulator, not a conductor. So I'm going to assemble these backwards too, just because that's what I'm used to. And I really don't think lock washers on nylon do you a whole lot of good. I'm going to put the screw side on the nylon spacer, and we'll put the lock washer nut on the back. That's the way I'm used to seeing them, so that's what I'm going to do when I put this one back together. Doesn't really matter. I think a lock washer grabs a little better in aluminum than it does on plastic. Plus the head of the screw allows the nylon insulator to get mashed down a little bit, whereas the lock washer will just cut into it. So I think you get a better squeeze and a better securing of the screw. So I'm going to space these somewhat straight. We're going to tighten them down a little bit. They always move when you tighten them down, so you kind of got to tighten them and adjust them, then tighten them and then adjust them, and repeat until you get them kind of to where you want them to go. If they're too tight, they're really hard to move. But test fit. Slide them into your holes on there, and then drop your board down. If your other two holes line up, you did good. If they don't, readjust. What you're trying to avoid is bending the legs on the devices when you screw everything down. A little bit of bend is okay, but you don't want them bending sideways, because you risk cracking the case of the part right where the legs meet it, and then you're going to have a whole bunch of other problems that you didn't want to have. So we're a little bit tight, but it's walking down, so we're going to be okay. So I will screw that in, and then we will be on to the dashboard, or the Pdc board, I'm sorry. I don't know what Pdc stands for, it's just marked on the board Pdc. We can call it a pretty dumb control board because there's no smart chips on there. No PWM ICs, it's just basically an oscillator circuit. And I can't tell you how it works because I don't understand all that stuff. But I do know that it is a self-starting oscillator. Don't go crazy tight on anything going to the board too. They don't like to use washers on this stuff, so when you're clamping the board down, you're really just digging into the fiberglass on there, and it's not all that strong. Get it snug, but it doesn't have to be crazy tight. I knew one of these was going to give me some trouble because of that green junk that was on the screws. not too tight going into the board. Alright, so now what we have left is the PDC board. Don't know, I was muted there. Hopefully I wasn't muted for too long. I must have hit the button on accident. We're cleaning up, and then we're going to move on to the PDC board, because this is usually the root of the problems. Alright, somewhat clean work surface, doesn't have to be spotless, just a little better. Let me get my testing. Yep. And this one does not have a bashboard in it. We need a bashboard. Luckily I have a couple laying around. I have more than a couple. We'll test a known good one first. And we'll just verify that this one is good. And these cannot be switched between boards. They have different values on them for some of the resistors and capacitors on there, and that's based off the transformer that they're switching. So if you swap boards, it might oscillate, but you are going to risk not having full output or having good output on your amp, because it's not going to be switching at the right frequency. So we are going to look for voltage, and I'm just going to check off of the two voltage regulators for around 30 volts. We're going to use our current limited supply because I don't know if this is a good or a bad dashboard. But what I'll do is I just throw these in here so I know they're making contact. If the board is good, we should get power. If this board is bad, these resistors are going to start heating up really quick. I'm not too concerned with the dashboard. I would like to know, well, this will be good. I'll mark it as good after we test it, but let's go current limited and power on. So we have 24 volts and climbing. Let's see if our resistors got hot. No. So we have power, and we can just verify that we have it by carefully checking these and making sure we have about 5 volts, 6 volts. Switch it off. Grab some safety probes And we will flip this guy over, and this cap definitely needs to be drained. And we'll drain the big one too. I'm going to check this one diode that looks a little weird before I even pop it in there. And you really shouldn't test diodes in circuit, but sometimes you can get a reading on them. And this one's testing good, so. Most of these diodes, if you get around 0.56 volts when you're testing them, they are good. Sometimes you have to pull them out of circuit. It depends on how they're connected. I need to go grab a file, so I will be right back. Alright, the reason I had to go grab a file is because when you have solder on these pins, they do not want to plug in to any sockets or anything, so I just take the file and I just do the top, bottom, and then I use my nippers to clean in between the pins. And you're not taking material off. All you're doing is just smoothing the high spots of the solder down. And if you don't have a testing fixture, well, then you're kind of out of luck. Kind of just got to put the board back in, test the amp, see if the power supply starts up. If the power supply starts, you're good. If not, then you got to start troubleshooting this board. But when you have a testing fixture, it takes a lot of the guesswork out. So clean up those pins and then it plugs right in. Hopefully all the pins were long enough to get a good connection, but we'll be able to tell right away if this board is good or bad based on what we get on our output. So we're going to current limited, never go full power. And it went to 0, that was interesting. Oh, we're on diode. Let's go to voltage. So the switching board is actually good. That is also a pretty rare occurrence. So if you would have put this board back in, you would have been good to go. Oh, I'm not on camera there. There we go. Switch it on, 25 volts, and climbing. Should be about 30 volts. If you're not switching, let's zoom in on this board real quick. I told everybody I'd zoom in, so let's zoom in. Alright, we're about max zoom. So if your power supply is not switching and you have a PDC board, this guy right here is usually the problem. And this is a diac. It's basically like a double diode, like two diodes connected together. It is a DB6 diac, which is a 60 volt diac. I will actually, I think I have a link on the Klipsch forums to what this part is. So if you find me on the Klipsch forums, you'll find a schematic of this, and you will find what this part is. But it's a DB6 diac, I know NTE sells the proper part for them. There's probably some other suppliers where you can get them from, but it's a DB6. That's usually the problem, and it's usually caused from glue. Luckily this board did not have a lot of glue on it, so the FETs died, but the PDC board didn't. I knew we were having a good night tonight. Okay, so power's off. We're going to disconnect. We are going to discharge. That one had some juice in it. That's why you discharge. 100 volts don't feel good, even if it's DC. So let's put the PDC board back in. We know that we're going to get some juice coming out of this. I instantly know why the nuts were not on this side of the board. And that is because these capacitors right here are rubbing. I gotta zoom back out. So I need to see how I can make this board fit in there. Or I'm going to have to take those out and flip it around. That sucks. I might move that part to the back of the board. Cheat a little bit just so I can not take those FETs back out. Yep, that's what we're going to do. So the reason that these screws are not in the position that I'm normally used to seeing them in is because they use these box style film caps instead of the bead style. If they were the bead style, this would drop right in. I don't know if this board is the same as this one, so I'm not going to do a swap on it. I don't want to measure everything out. Maybe I will. Not the same. Wait, hold on. I was reading the wrong cap. 332. Actually, it is the same board. So here's one of the ways that you can tell the difference between them. And again, we're just getting lucky after lucky. But the resistors on the top will be a different value, as well as, well, here, let's see if I have another one. We'll do a side by side. This is educational, so it's worth wasting everybody's time. Let me grab a board. of course, when I need these boards, I can't find them. Here's one. Nope, not it. That's for a different model. So I have blanks of these boards, and I have them in like a little kit so I can reassemble replacements. But I am still a little disorganized, and I apologize for that. So they're probably on my shelf somewhere. I will check one more place to see if I can find them, and if not, we're going to have to move on, and I'll cover it in a future video. The way to tell the difference between them is by the component values on the board. I'll eyeball around a little bit while I'm doing this to see if I can find some more. But they're probably put away. They're probably packaged up in a bag and in a box somewhere. But the resistor values, and I'm pretty sure it's these two. Actually, I know how I can look this up. I'll just pull up the board. You guys won't be able to see this because I don't have my screen set up to share, but I will be able to get you the right information. So this is a 66038RA. So R5, R6, C2, R2, R3, and C1. Let me pull up the board so I can show you where those are. So R5, R6, and so here's R5, R6. That's these two on the outside. And then R2, R3 are here. And C1 and C2 are here and here. And if we are looking at the other common version of that, these caps are 4700 picofarad, and these resistors are 1.1K. On these, we have 330 or 3300 picofarad, and the resistors are not going to be 1K. They're 373. They're in parallel. Let me find the value. I'll look the value up real quick. Purple, green, black, black, and brown. And no, I don't have my resistor bands memorized. I know there's like a little thingy you could use to memorize them, but Google works too. So it's a 5-band. We're going purple, we're going green, black, and black. 750. 750 ohm, 1%. I know the brown is 1%. So if we go from 1.1K to 750. And as far as I know, there are only 2 versions of this board. There might be more. But if your caps are the same and your resistors are the same, you can switch the ports. Here's a quick and dirty test. 375 ohms. 373 ohms. 4. We're within 1%. Again, we got lucky tonight. So, now that I don't have those ginormous film caps in the way, I'll do a board swap and we'll be in business. And I know this board's good because we already previously tested it. This will become my new testing board. And just for the heck of it. So yeah, this board I did replace the diac on here. These are typically blue on what color is this one? They're typically blue from the factory. Well, this one's black, so that shoots that down. But typically these are blue. Apparently some of them are black too, maybe on the newer versions, but on the sub 10s and sub 12s a lot of time they're going to be blue. And again, that's a DB6 diac. Or if you want to get technical, it's basically the magic behind the power supply. The magic make it happener. Solder the FETs in. Be generous with the solder on the FETs. Don't bridge the legs together, but put enough on there so it's going to wick down the through holes into the other side. Make sure you get a good joint on there. Alright, we are at a point now where we can do a functional test. We should be able to power this guy up, and we should be able to get something out of the CD plus and CD minus. So we're going to try that right now. Make sure our polarity is correct. I'm just going to stick them in there. We're going to power up current limited. Now, if there's any shorts or any sort of weirdness, you know, our current limit should keep the board from killing itself. We're limited to about 1 amp max on the input. So we're going to flip on the current limit and see if we get power out of the supply. And we do. We get 8 volts. So this supply is back in service. Drain our caps. I like showing draining the caps because I want to make sure people do this if they're working on this. There is juice in these bad boys. Let's see if we can get it on camera. Well, that one's good. Check the mains. Nope, little spark. But still, drain your caps if you're working on that. Alright, power supply is done. Now the rest is just preventative maintenance. Unfortunately, there's really no easy way to work on these. You got to pull the amp board out. But what we're going to do is we're going to do a recap on this board and a recap on this board. And the reason why we're doing that is these regulators get screaming hot. So I usually bend them out of the way just to get them away from the caps that are sitting behind them. But they get hot, and eventually these caps get dried out, and it's going to kill the caps. And these are, what are these? Are these Junfus? Yeah. Yeah, these are Junfus. So we're going to take out the Junfus, and we're going to put in some good caps. So preventative maintenance is really what this is. Remember how your cables connect? This one's marked, so the cable on the inside says to feature. This is your feature board, and then this one says to main, and this power supply is main. So we're gonna have to deal with some of our favorite white goop, unfortunately. I typically recap the entire amp when I'm working on these. It's not that much extra work, it's not that much extra cost, but it is extra peace of mind. And I don't want to see this thing come back, so I'm going to do it right and be done with it. I'm not really a big fan of these like little spring steel heatsink clamps. They could have did better with those. I like the nylon insulators that go actually through the device and smash the device into whatever you're trying to clamp it onto. I think that's a better approach. But for some reason, Klipsch seems to love these things. Now, some of our favorite glue is always on these holding the little thermal device down. So if you just rip this thing off the board, you're probably going to damage that. Just take a little heat. You still got your heat gun. Warm up that glue. And then it comes off pretty nice. I generally take the glue off and just lean it up against the plate. The glue doesn't really help anything. It's like a rubberized glue. If anything, it's an insulator. You probably gain something by getting the glue off the contacts, though. Eliminate a potential short. I don't know what happens if these short. I believe it, I don't know. I don't know if they're positive or negative coefficient sensors, so better to just clean them off and get the glue out of there. Less headaches. Have a paper or something so you don't get silicone all over your work mat. Now, I have noticed that sometimes these bipolars go bad. It seems to be kind of hit or miss. The resistors on these generally tend to be pretty good. And very rarely do the outputs blow. I've had some with blown outputs, but it seems to be a pretty rare occurrence. So those are typically your failure points. Most of the time it's going to be the MOSFETs and the Pdc board. Pdc board is usually the culprit. I think we got lucky today, but it doesn't always happen that way. So we're going to do one at a time, just so we don't screw up what the cap values are. .7, 35 volts, and bipolar. There are two 3 bipolar caps on here. And these are pretty decent amps. I like these amps. They're very similar to the sub 10s and sub 12s. They just use separate boards. I think the circuits are nearly identical. So if you have a schematic for a sub 12, you should be able to work on this, even if you have no clue what you're doing. And I generally don't know what I'm doing, but I've just worked on these enough to where I've learned what's bad and how to fix it. That's part of the fun, though. That's why this is my hobby and not my job. Oh, look at that. We got lucky there, too. So sometimes the pins will come out if they stick to the iron. Can we do 2? Nope. Tweezers will pull it right out. And these leads aren't bent, so figure that one out for me. Why are the leads on the power supply bent, but the leads on the amplifier board are not? I think my solder sucker is due for a cleaning. So I put a little piece of paper towel down over the bottom of my little vacuum nipple in the bottom there. And the only reason I do that is because I was getting flux buildup down there, and I had to replace those little rubber parts. It seems to block some of the flux residue and make the rubber parts last longer. So, neat little tip. Alright, what did I do with my cap? I lost my cap. There it is. So we'll cover this again. I know I've talked about it before, but if somebody hasn't watched any of the other videos, the negative lead is typically the shorter lead. You can check to verify that on these bipolars, but I typically just follow that convention. Square pad is positive, and round pad is negative. Whether or not it has an effect, I don't think so, because I never really paid attention to it before, and I've never had any problems. But I know on some electronics it really makes a difference. Typically I think that's on like tube amps and things like that. If you watch Mr. Carlson's videos, he's always talking about the outside foils. So I'm pretty sure that it has a significant impact on the stuff that he's working on. As far as like a solid state amp, probably not as much. Especially since the way that these operate is a little weird. Always check your caps too, because I almost had some cap contamination there. Again, this takes a little bit of time, but it's not a deal breaker. A few extra minutes to do a full recap on an old amp, like this thing's basically going to be brand new. As long as the woofer's in good shape, like you'll get at least another 15-20 years of service out of this thing if you turn the power switch off. If you leave it plugged in and turned on and standby for 24/7, I'll be seeing this thing in 5 years. Standby mode in Klipsch subs is a myth. There is no such thing. The power supplies never go into standby mode, ever. They are always on and they are always generating heat. All the standby switch does is mute the outputs, and it does save power, but it doesn't save capacitors. You switch your gear off, ow, that one got me. You switch your power off and they will last much longer. $22.50. So a few more caps and we'll be ready to test this guy out and we'll be done. And I really got my finger that one hot lead. Even with calluses, that one hurt. I'm going to have a little blister there tomorrow. Give me something to whine about. We might not be able to cut all these out. I'm going to try to keep doing it, but sometimes you got to desolder them. I'm going cap by cap because I don't have a cap map, as I call it, for these, so I don't know which values go where. So this is the safe way to do it. So I'm making sure that I get all the right values in the right spots. We're going to try and not touch the hot leads this time. Let's not melt holes through fingers. That's not fun. And we'll desolder the rest, just because they're kind of densely packed in there, and that'll make it a little easier. We got a handful of caps on the other board. Those have bent leads, so those will snip off. These we can use the solder sucker and clear them out. So the two big ones, I believe, are 135 volts, and the two small ones are 4750s. These are the filtering caps for your op amps, so you want to make sure that these are good. You want good filter caps on your op amps. Just restocked most of my caps, so we should have everything ready to go. Leave them spaced off the board a little bit, doesn't hurt nothing. You don't have to smash them down. I can't tell you why the holes were not properly sized for these. So they actually do sit flush to the board. That one blows my mind. But again, that's also not surprising because the large 1000 microfarad cap was not placed properly in the holes either. So I don't know, manufacturing defects, maybe a late part change. They went to a different can size or different cap size. Could have been some kind of cost reduction thing. I don't know, but it's a lot nicer when they sit flush on the board versus being spaced up. Almost done with the amp board. Check your polarities too. Make sure your polarities are right. Double check, triple check. Check as many times as you need to. Make sure you got the right caps too. Yeah, that's got to come out. I goofed on that one. Double check. We want 50 volts on our 47, not 35. I grabbed the wrong bin. Easy switch. I haven't had enough coffee tonight, that's my excuse. But still, it's good to double check, triple check. Make sure you check your work, because you will make mistakes. And if you check it, you'll usually catch them. This would work with 35 volt caps there, but it's very close to the voltage input to the regulator, so it's better to just put the higher cap in there. It'll last longer, it'll be happier. In a pinch, I guess you could do it, but you always want to go to a higher rating when you can. I mean, you could go crazy too if you want. You can make these all 100 volt. It's not really necessary, but you can always go up. You shouldn't really go down. There's a reason why the designers picked those values. But the high quality caps are a little more forgiving too. So anybody that is following along, I did get my website to a functional stage of operation. The waiting list is now live and active. If you're trying to get slotted in for a repair, you can head over. The link should be in the description. And you can put your name on the list, and when I can get a chance to get to you, I'll repair your amp for you. I do this as a hobby, and I do it as I have time. So if you are in dire need of having your equipment repaired, you probably should not ask me to do it. If it's been sitting in your attic for 10 years and you don't mind if it sits on my shelf for a month, then yeah, sign up and send it on out. I'll take care of you. I can guarantee you'll get a good quality repair. A lot better than some of the ones I've seen, I can tell you that. Alright, almost done. We can't put this board in yet. We still got to recap the feature board. That board's got a few caps on it. This guy's been waiting for his amp, so we're going to make sure he gets a quality repair for his patience. I have had some people rush me. Sometimes I take a little bit longer than people expect, which I understand. They want their gear back. So let's see. Yeah, we got 1, 2, 4, 7 caps on here. It won't take too long. Typical failure on these is also the RCA jacks and these switches. Somehow these switches always manage to get broken off. That's an E-switch. They're readily available. I shouldn't be giving out all my secrets, but I feel like I'm at a point now where I have so many people asking me to do repairs that if somebody else wants to do some of them for me, hey, feel free. These are kind of a pain to work on. So yeah, we'll go through and we'll replace all these, and then we'll fire this thing up. I'll throw the little scope on again so we can see the output. These leads aren't bent that bad, so I'm going to try and suck them all out. 2235 bipolar. I'm running low on those. One of the fun things about doing the repairs like this and blogging them on video is, whenever I finish one of these for somebody, I send them a link to the video. And I don't know, I've gotten pretty good feedback from it. A lot of people seem to enjoy watching their amp be repaired. I'm doing it more for the ability to record what I've done and kind of as more of a blog for me, but everybody that I've done a repair for really seems to get a kick out of watching their amp be fixed. So it's kind of cool. I'm glad that I finally bit the bullet and decided to do this. It's not the most exciting work. I don't think I'm going to get 1 million followers fixing amps, but hey, I'm still having fun, so that's all that matters. Having fun and providing information to people. Can't really go wrong there. Plus, I feel like more people need to learn how to fix stuff anyways. Everything ends up in landfills. I'm doing society a service by repairing amplifiers. So far I've been lucky with the bent leads. I've been able to use the solder sucker on all of them. Your mileage may vary when you're doing this on your own. I can't guarantee it won't be frustrating. That's what takes most of the time on these, is getting the parts out without doing damage. If this was through hole, it would really be a walk in the park. Because through hole, you can just use a pair of hot tweezers and just pluck everything right off the board. 4750. Now, if you were doing a poor man's or a lazy man's repair, I would say you really don't have to go through all of these steps. I mean, it's almost guaranteed that after you got the power supply working, this would still work, but the question at that point becomes for how long. This is a little hard to see. Let's get some light there. So, you know, a little bit of extra time. Yeah, it's a pain, but you're going to have a sub that you can enjoy for a long time. So endure that pain and make your sub happy. Do the right thing for your sub. That guy was installed in there nice. It's hard to see. And leads are, come on, focus. Well, it ain't gonna focus, but these leads were just severely bent over, almost shorting, about a millimeter away from shorting. 4.7 and 50 volts. That's a pretty popular Sunfire cap. We got a lot of them. Again, all these caps I'm using that are polarized are the UPS series from Nichicon. Good caps. I'm pretty sure they're tier 1, according to the Bad Caps forums. I haven't heard any bad things about them. They seem to work pretty good for me. Two more and it's test time. Another 4.7 and 50. Check our polarities again, just for a sanity check. We're good. Two of these caps, I believe, are extra filtering for the op amps, and one of them is for the timer for the auto on circuit. The auto on uses an RC timer. Which is kind of weird, but it works. And we put that cap in backwards, not paying attention. Chalk it up to being late. I'll flip them around. But still, we're checking our polarities, we're making sure everything's in right. So we have a successful power up. I don't know how I missed that, but it's okay. Last one. And I'll still call this a win because even though the leads were bent, we were still able to get them out. 47 and 50. What's our time? 2 hours, not too bad. Probably could have went a little faster. But not too bad. Trim our long leads off. Make it look nice. Check one more time to make sure our polarities are good. Make sure all our negatives are in the right spot. And they are. So now we can start reassembly. I'm not going to clean off the bench yet until the plate's put back together. Then I'll get everything cleaned up and we will fire this amp up. I am going to pull this little bit of gnarly glue off down there. We don't need the hot or the soldering station on anymore. That can go off. Save the heating element. And there is a little bit of glue on the bottom of this board, but it is not a critical spot where it needs to be cleaned off. It's just holding the RCA jacks in, so we're going to leave that. And the only reason I'm scraping this off is because I want to make sure that I get contact for the temperature sensor. And I believe how this part of the circuit works is as the components start to heat up, it reduces the volume. And reducing the volume reduces the power level going into the devices, because the power supply tracks the volume. So when the volume is high, it turns the power supply rails up. When the power is low, it turns them down. I think that's class H or G, tracking power supplies, something like that. If you Google power supply classes, it'll tell you which ones use rail tracking. This is always the best part, putting it back together and then firing it up for the first time since who knows when this thing died. And it's kind of like being a doctor and like saving a life. Like, granted, this isn't as cool as like saving a person, but I mean, I saved something, so it's a little bit cool. I do have a pretty steady hand, though. Like, if I could have made it through medical school, I probably would have been a pretty decent surgeon, but who has time and money for all that? Very few. Plus, I don't know if I could handle all the blood and guts. I mean, I don't mind it, but certain things freak me out. I don't like eyes. Plus, if you're a surgeon, you see, like, some horrible things, so I don't know. Working on amplifiers is probably a little better. I mean, I get sad when I see a board that's like burnt to a crisp, but I don't think I could handle a human that's burned to a crisp. That'd be a little too much. A little too much for me. Alright. Put the power supply back in. Let's hook up our wires. Make sure we hook them up right. Feature board is this one. Main is the power supply, which is weird. I don't know why they call it main, but they call it main. Little silicone booties are not critical, but if you can put them back, put them back. If you can't, well, don't. Now, if you have an amp and your power supply is completely trashed, you can go on eBay and you can find one of these amplifiers and you can do a power supply swap on them, as long as it uses the same one. I've had to do that before. I actually had a board that was caught on fire, and the board was burnt so badly that it just did not make sense to repair it. I'm sure it could have been repaired, but I mean, the board was burned all the way through. And what I ended up doing is I just bought a amplifier that had the same power supply, switched out the supplies, and repaired that one and called it a day. So you can take some shortcuts, or you know, even an amp that's really beyond repair can still be fixed as long as you can source a part for it. I have a couple of sub 10s and 12s that are heavily burnt. Maybe when I get caught up on some of the other stuff, we'll tinker with some of those. And I am going to do some sub 10 and sub 12 videos. I have a lot of requests for that. And that is one of my favorite amps. I don't know why I like them so much. I just think they're good amps. It's the same as a Bash 300S that you can get at Parts Express. And those are pretty good reviews. The Bash 500S is like a RW-10 amp. Those are pretty good. I don't know if it's an S, it's a Bash 500. But I like the Bash 300s are one of my favorite amps. I think they sound nice. They're not terrible to work on. They put out a decent amount of power. You can run a pretty large driver with those amps, especially the 12. Alright, we are back in. All we need is our feature cable, and then a quick little cleanup. Now if you want to be a little extra finicky, you can separate all the wires in these ribbon cables and they bend a lot better, but it's not really necessary. It's just more for OCD than functionality. Let's get the bench cleaned up, get the tools off, get the metal off, get the bad caps off, and get ready for a test. I love working on these silicone rubber mats. They make cleanup really easy. Gotta keep a clean workbench. I was not really good at doing that before. Alright, so this guy was saying that it blows fuses. I'm gonna guess that we have a blown fuse, and this fuse is gone. You probably can't see it, but it is smoked. So this is a 2 amp. The 10-inch versions are usually 2 amp, and the 12-inch versions are usually 3.15. But again, you know, don't put a 5 amp fuse in there. Put a 2 amp fuse in there. If you can't find a 2 amp fuse, go on eBay. Like, I have fuses listed on there. You can order them from DigiKey. You can probably even get them on Amazon. You probably have to buy 200 of them, but I'm sure you can get them. Just get the right fuse. Don't cut corners. So, alright, we're going to put this on my little fancy amp rack here. That way we can kind of see what's going on. We're going to turn the low pass all the way up. We're going to turn the volume all the way down. Phase all the way down. Oh, wait a minute. This has external volume control. Yep. I don't remember which pins it is. So I made a little external volume control. I'll have to dig that out. I knew we'd come across one of these one day. I hope I can find my volume knob. So yeah, some of these Klipsch amps, you're going to run into that too. They do not have a volume pot on the plate. So if you're working on one of those and you need to check it and you don't have a volume pot hooked up, you're not going to get any output. I haven't worked on one of these in a while, so I got to find my volume pot. That is an important part to have. It doesn't have to be anything fancy. I do have some extra pots. I have some pot knobs. Where is my tester pot? That is an excellent question. Well, we might have to make one too. We can always do that. I don't recall what the value of those is supposed to be, but if you get close enough, it'll probably work. I'm going to check my storage boxes here to see if I can locate this thing. So I'd rather not have to make one, even though it might be faster than trying to dig up the one that is missing right now. Give my bins a once over, and then we're gonna have to make a volume pot. Can't end the video without a good test. That's no fun. Well, I got a pot. That's not my one that I normally use, but I have one. I used to use these to fix definitive technology amps, but I don't work on those anymore. They're a big pain to work on, and it's just not worth the time. Throw them out. If you have a definitive technology and it's got a bad preamp, throw it out. If you really want to work on it, it's these pots, but the pots are going to continuously fail because they draw too much current through them and it burns out the carbon on them. Really not a good fix for those. I've tried a few different methods and, a few different ways to get them going, and I cannot figure out how to keep the pots from killing themselves. I'm checking my bins and stuff one more time because I thought I had this thing in my box. I want to say it's a 20K volume pot, and only 2 of the 3 pins are used. So we'll have to go through and find out which 2 are used, then crimp a connector on there. I know I saved that thing when I switched to the new bench. I would not have thrown that out. One quick glance on my shelf and then I'll make one. Well, no luck on that. We're going to have to make one. Apologize for that. I was not prepared. It happens. It's late. So if I remember correctly, 2 of these pins are shorted. On this one, no pins are shorted. Let's find out which one is. See if any of them are ground. So the center one is ground. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So we will try to put the wiper in the middle and see what happens. And there's no schematic on this, so there's really no easy way to figure this out. And I'm not going to know if we're at maximum volume, minimum volume, or anywhere in between. It's going to be 100% guesswork. So we definitely will not have anything hook up to the outputs except for the scope until we figure out where we're at with the volume. And we'll probably have to switch the pins around a couple times. We're just barely going to fit. Well, at least for future videos, if this this pot works, this will be my new volume pot because I already have some nice silicone wires on it. Molex multi-crimpers, definitely a good tool to have. It does every size. They're a little bit thick, so some of these small pins are a little hard to do, but it's the only set of pin crimpers you will need. And so the silicone wire is pretty awesome too. I try to use silicone wire on, pretty much anything that I do. I mean, it's ultra flexible. You don't have to really worry about it breaking off at the solder joints, and it's just good stuff. I'm going to go with a small crimp on these, 1.6 millimeter. I might need to go down to, actually I'm going to go to 1.4, go to the smallest. And the reason for that is these wires are already a little large for the connectors, so I want to make sure that I get them in there. You don't have to crimp these on, but if I'm making this, I want to be able to use it on, more than just this amp. So I'm going to make sure I do nice crimps and make sure the wires fit into the connector, and I'll mark this and save it, and hopefully I'll be able to use it for the next one that I need. These wires are a skosh too big. We can cheat a little bit. Enlarge the holes and break the connector at the same time. Try again. Good thing I have more. This time maybe not ram it in there so hard, just enlarge it. I'm using my probe to widen the hole so I can fit the oversized wire in there. Again, this is killing a ton of time, but I have no other way to test this. Looks like it's going to be a 1.4 crimp all around as well. These are standard IDC headers. I have them left over from when I was doing some stuff on my 3D printer. They're pretty common in computers and all kinds of stuff, so they're good to have laying around. it'll make a decent decent little test pot. It sucks we have to make one, but what can I do? I don't know where my other one is. I believe the RW series also has an external volume pot. Actually, a lot of Klipsch amps have external volume pots. So if you're going to be doing repairs, keep that in mind. That's something else that you're going to need. You're going to need a way to control the volume on the stuff you're working on. Wire sliding much better with 1.4 crimps. Still about maximum for what this connector can handle, but still much better. Alright, now we have it's not going to go in, darn it. Did it go in? Yeah, yes it did. No, it didn't. I gotta trim this last one. The rubber's sticking through the crimp. And of course it falls right into the hole. Are you kidding me? This amp doesn't want to get tested tonight. It's fighting me. Alright. We almost have a volume pot to test with. Can't seem to get this last wire to go in. The silicone wires, the jacket's just a little thick on these. They're not really made for these connectors. I'm just trying to throw it together because it's something I had in my bin and I don't feel like soldering all kinds of extra stuff, and I just want to get it done and chill. So I know we're sucking up a lot of extra time here, but at least I'll have a decent volume pot now. I'll put a connector on the other side too, maybe for something. Not right now though, we'll save that for later. We don't need that for what we're trying to do. Okay, let's get back to it. We are not hooking speakers up. We are going to hook up speaker wires. Actually, no, we're not even going to do that. We're going to go directly into our scope. And the reason why is I want to make sure that we have some form of output, some form of usable output before we go into the load. I don't want to send max volume into the 4 ohm load I want to make sure that we test it first. Make sure that the amp is good. Make sure that everything's happy, and then we can start throwing the juice at it. But I don't want to do it right off rip. I want to make sure that everything's good, that the amp is happy. And the best way to do that is we're gonna take a look at the output. So I'm gonna clip a probe on there if I can get one to stay. These little grabby things kind of suck. These are actually going to get cut off probably tomorrow, and I'm going to put ring terminals on them and permanently attach this to my outputs. I will find a better set of grabbers that I can use for hooking onto these things. I need a set that has a bigger hook on it. These aren't bad, they're just not ideal for what I use them for. Alright, we have our little battery powered super scope. We're going to stand our amp back up on our rack here. Get a proper power cord. We're still going to test current limited. But we're going to use the actual power input. And since we don't know what our output state is, we definitely want to start off current limited, because this thing might be set to maximum volume. So it's very possible I do not have the pinout correct on the volume pot, so we will find that out right now. Alright, we're starting off at 50 hertz. Let's see what happens. We're going to leave it on auto on. We're going to throw the power on. We got a green light, and there we go. Let's see where the volume's at. So yeah, the volume pot is definitely not in there right, because you can see the waveform's getting all messed up. I'll have to try and find out how that goes, because we're going from nothing all the way up to basically full output. So yeah, it doesn't get much louder than that, but we do have a nice clear clean sound wave. We're reading 54 hertz. It looks very nice. The nice part is we're not overheating our amp, because we don't have a load on it yet, but you can see the sine wave as I zoom in. I wish there wasn't so much glare on that right now. But that's a beautiful sine wave. Let's widen it and make it fat. And I'll just move the wave up and down. You can see that there's no glitches in that wave. Like it's a very, very clean waveform. So that is what we want to see. This amp is back in service. It is good. I will have to figure out the volume pot so I can actually get better control of the output. I'll add that onto my to-do list. But this amp is done. So I appreciate everybody following along. I know this was a little drawn out, but we did cover some new topics. We learned a few things. I explained a few things, so hopefully this will help somebody work on one of these amps. These are very similar to the RW-10 and 12D series. They share common power supplies, common amp boards. The feature boards are a little different between the two different versions, but if you can repair, any of those, you should be able to repair this one, or if you can repair this one, you should be able to repair any of those as well. So I'm glad we made it through. If there's any questions, please feel free to post them in the comment section. I'll try to answer them as soon as I can. Remember to like and subscribe if you like watching these videos. Please give me some feedback. I'm always looking for some more feedback on how I can make this stuff better, or provide more information for everybody. So I appreciate you for tuning in, and have a good night. Thanks.